There you go. Okay, so here we go. Today's date is 1/11/22. So our objective today is really finding the length from a point to a line and between parallel lines. Okay, write that down. I'm going to find the length from, sorry that's so sloppy, a point to a line and between parallel lines, okay? All right, so let's define the following. So we know perpendicular lines have opposite slopes, but that's not a very good definition. I want you to write this. In fact, this question's on your test on Thursday, so hopefully you're going to write this down. This question right here. So they're negative reciprocals. Negative reciprocals. Reciprocals. Because you guys don't like to use the word opposite, but opposite kind of weird, but negative reciprocals really does it. Okay, negative reciprocals, and that's what you want to write on Thursday's test. It's going to say, what do you know about the slope of lines? You can say they are negative reciprocals. Don't use the word opposites, because opposite's not quite correct. Opposite doesn't really mean anything. So now let's take a look at how that's going to help me with example 1. So the first thing I'm going to do, I'm going to call this line L. Okay, am I going too fast? Yeah? Okay. So I need to know something about slopes, right? So line L has a slope. I know it's 3. Does that make sense? Now I can see up 3 over 1, up 3 over 1, right? So the slope of the line L is 3. So I need to know that. So line L, its slope is 3 over 1. So what I would like is the perpendicular slope. I need to know that. What's the perpendicular slope? I should have called it -1/3. Thumbs up. You guys agree with what she said? Take a look. So don't say opposite because that doesn't make any sense, but negative reciprocals does. So now what I'm going to do is try and draw the line. So I'm going to try and draw that line. And let's see what kind of colors I have. Now this will work. So let's draw the line. What line am I talking about? Well, this line right here. So it's going to be perpendicular, right? It's going to be like that. Does that make sense? Like that and perpendicular, right? So instead of here, I'm going to go down 1/3 and I'll get it, right? Perpendicular slope, right? So I'm going to go to draw it, I'm just going to go from my point. I'm going to go down 1 from my point, down 1/3, down 1/3, and I can draw my line, right? Okay, and I'm only going to draw this part of it because I know that is perpendicular, okay? How's that? Well, now, if I want to find the length between these 2 points, I need to label this point. I know this point right here is the point, let's see, 2, 6, right? So I want the length from -1, 7 to 6. And I'll stop and let you catch up so this makes sense. Just let me stop and let you catch up so it makes some sense. Great question. Where do they intersect? Good question. I drew the line, boom, where do they intersect? They intersect that 2, 6. And I need to know that. That's the point of intersection. Okay, that's the solution. Okay. So when I drew the line, I stopped right there because that's where it touches, right? And that point where it touches is at point 2, 6. Does that make sense? So what I really want is this. I want this line segment. Okay. Let me call that point B, just because it's easier. I'm going to call that point B. So I've got A and B. I'm going to call that point B. It'll make it easier for me. So I got A, and here's B. So let's find the length of AB. Okay. Well, I'm just going to use my formula, right? Distance equals, or already make a right triangle, right? If you like the right triangle way, just use the right triangle. I know my formula. Well, if we don't have a formula, let me write it down. Let's write that formula down so you guys have it. I want to make sure you guys have the formula, right? If you don't have this, please get this somewhere in your notes, right? I think I've written it several times, but that's our formula, right? So, I guess first point, x1, y1. Second point, x2, y2, right? And I'm going to go ahead and put down my x2, which is 2, subtract my x1, which is a -1 squared, just use my formula, plus y2, which is 6, subtract y1, which is 7 squared. I'm just putting these points into the distance formula. Now I just need to simplify, okay? So I'm going to go and make this double negative, right? 3 squared plus -1 squared. Right, which is 3 squared is 9, and negative times negative is positive, plus a positive 1 because 1 times 1 is 1, and I get the square root of 10. The square root of 10 is a fine answer, or we use our calculator. It's about 3.1. Square root of 10, about 3.1. Pretty sure it's 3.1. Oh yeah, 3.16. Okay, thumbs up. Good. Example 2 is a little bit different, but not a lot. You just have to draw the line first, okay? Same exact problem. Number 2 is exact same problem. We just have to draw the line first. So we know we start at -6, y-intercept 1, 2, 3, 4, 5, 6. To graph this line has a slope of up 1 over 1, up 1 over 1, up 1 over, okay? So the line I want to draw is right here. Okay, so I just drew my line. Now it's got a point at -9, 3. All right, well, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So there's my point. I'll call point A, right? So it's identical to the problem that we just did. We just had to draw the picture first, okay? Same problem, right? So what did we do? We first found the slope, didn't we? Slope of this line is 1 over 1, okay? And that slope is 1 over 1. So m is 1 over 1. So what's the perpendicular slope? Yeah, 1, -1, or -1, 1. Great, good job. So I'm going to start at point A. And I'm going to walk my way towards this line, okay? I'm going to start here and walk my way towards it. But I'm going to walk by going over 1, down 1, over 1, down 1, over 1, down 1. And that's going to walk me all the way to here. So I'm going to go 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And then, Elsa, right there, right? That's my point, right? So I'm going to call that B when I get done locking that point in, okay? So let's draw AB. So I'm going to try and draw AB again. So let's draw AB. So I know I'm going to start at A and go down 1 over 1, 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 down 1 over. Okay, so here's AB. Okay. A is the point, -9, -3. And B is the point, well, let's see, B is at 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So B is at negative, oh, that's weird. -3, -9, that's, look at that, that's weird. I did not make this problem up, honestly, did not. It just happened to be that way, huh? All right. So, how do I find the length? Hey, should we do it Artie's way? Let's do it Artie's way. Let's do this one different. I like Artie's way, huh? Bailey, you like this way too, don't you? Or instead of the distance from, can you see a right triangle? You see a right triangle there?
Yeah.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? A squared plus B squared equals C squared, or 6 squared plus 6 squared equals C squared. We could use the distance formula, but isn't this easier? Isn't this easier? So I'm just going to go, all right, I'm going to go 6 squared plus 6 squared equals C squared. Right? Pythagoras theorem. 36 plus 36 equals C squared. Add them together. 72 equals C squared, but you have to take the square root of that. We just did that one in our warm-up. What was the square root of 72? You guys remember it? 8.4, yes. How am I doing? Does this seem easy? What do you think? Fairly easy? Good? All right. Now, because of time, let's turn the page. We'll do one problem back. Okay? But are you getting it? So this is what you're going to see on your test on Thursday. A problem like this.
Okay. What else is that like most of the past few years?
We got those parallel line stuff too. We'll talk about it tomorrow. I got a nice review ready for you. Okay. All right. So we actually don't need to do example 3. Okay. We don't need to do example 3, so I'll stop there. What I want to do instead is get the homework out to you. Page 299. I want you to do 1, 3, and 5. And I think that's all we'll do, okay? 1, 3, 5. Just 3 problems, okay? Yeah, you bet, goody. Yeah. 1, 3, and 5, and that's all we'll do. Okay, get your books out. We have 20 minutes to get that done, don't we?